Just wait for 2 minutes.
Okay, ma'am.
How was your test, Razi, that IMP1?
What, ma'am?
How was your test that IMP1? You
Ma'am,
got
yes, ma'am. I got, I think, 24.5.
24, 25. Let me check. You got 25 out of 30. So, and which question you didn't do?
Ma'am, can you wait for 2 minutes and may I find my test that I gave?
I have this one. Let me show.
Okay, ma'am.
Where's the Razi? Here in this one, 0.5 marks deducted, and this ninth one is wrong. Now that numerical question maybe.
Yes, ma'am.
Okay, and these two, the invisible, visible, okay, but here 5 marks deducted. Okay. What was the 10th question? Let me check just a minute. Okay, the 10th one was two liquids which are the second one. The liquid having higher density will form the lower layer. So you wrote which has less density. But see, Razi, the 10th second one, the question was which of the liquids will form the lower layer, right? So the liquid having higher density will form the lower layer, not the less density will form the lower layer. Okay, the higher one will form. Okay. And what about the third question? The what is the basis of this method? So you wrote separating two immiscible liquids is the basis of this method. So the answer will be the method is based on the difference in the densities of two liquids, not the immiscible liquids. Okay.
Ma'am, what method is based for, ma'am?
See, this method is based on the difference in the densities of two liquids. Density. Okay.
Okay, ma'am.
Yes, and the second one was the higher density, and the numerical was wrong. No, you didn't write only. Okay, this numerical was this one was easy, na? It was quite easy.
Yes, ma'am. Ma'am, I forgot to multiply 100.
Acha. Oh, हाँ. 110 upon 550 into 100. Okay, yeah. Okay, so. Okay, good marks. What about others? Why they are not joining the class? Where's everybody? Okay, so should we start?
Yes, ma'am. We can.
Okay, so let's start. So here, just a minute. Here, that day we discussed about atoms, right? Atoms, huh? So,
ma'am. Ma'am, the 9th question I did at last, and I did correct, I think. Ma'am, the answer is 20%.
9th one you did at last. Okay, this one was correct. Good.
That's why I thought that I did this one.
Yeah, it's correct. Okay, so here, what about atoms? Atoms we already studied. No? We all know this about the hydrogen and oxygen. These are what? These are the elements. Elements is of two types, the metal and the non-metals. And here the smallest unit of hydrogen is what? Is H, and here it's O. So what is element? Element smallest entity is known as atom. This is the element, and the smallest entity, the smallest part of the element of an element is known as the atom. And this part also cleared, right? Razik, you have to write these three things: the proton, electron, and the okay.
Ma'am, the combination will vary, no?
The combination. The three combinations, yes. If you will write only the protons and neutrons, then you won't be able to find, right?
Yes, ma'am.
So let's talk about the molecules. What is molecules?
Ma'am, a group of atoms.
Yes, a group of atoms where more than one atoms are chemically bounded, right? So compound smallest entity is known as molecule. I'm writing only M. Okay, M for molecule. Like for example, if I am taking water in this beaker, water is what? H2O. So this H2O is a combination of what? This H2O is a combination of two atoms. One is hydrogen and the second one is oxygen, right?
Yes.
So where more than one atoms are chemically combining, so the combination is known as the molecules. This is the molecules. Your NaCl is molecule. Here two atoms, the sodium and the chlorine. Okay. So now see this. Do you know the name of the scientist?
No, ma'am.
Okay. So the name of this scientist is Lavoisier. Okay. And no, what was that? Antoine Lavoisier, and the name of this one is Joseph L. Proust. Joseph L. Proust. So what they did actually, these two scientists, they actually laid the foundation of chemical sciences by establishing the two important laws. They established what? They established two important laws of chemical combination. They established established 2 important laws of chemical combination. Now, what are they? Do you know?
No, ma'am.
Okay. So the first was law of conservation of mass. Law of conservation.
Ma'am, in the assignment we got questions with these laws, I think.
Your assignment
Ma'am,
was A1 maybe, no?
yes, ma'am, and there was these types of questions like two elements are mixed, what is the density and the law is here, and like that. What was the
So
mass? And
you did or not? No.
yes, my first time I did, it was wrong, but Somi ma'am told me, explained me, and then it was correct.
Okay, which question? Let me just see. A1 of A1 of ANM, right? Just a minute. Okay, I'll check in the last 5 minutes. Okay. So these two scientists gave what 2 important laws of chemical combination. One was law of conservation of mass, and the second was law of constant proportion. Law of constant proportion. You can also write definite proportion. Okay. So these 2 important laws was given by these two scientists. Okay. One was law of conservation of mass. Second was law of constant proportion. Now we'll discuss what is law of conservation of mass. So where should I write? Just here. Okay. So law of conservation of mass. Do you know where Shazam and where Zadvika? No?
No, ma'am.
Okay. Law of conservation of mass. Now, what is the definition of this law of conservation of mass? It states that mass can neither be created nor be destroyed in a chemical reaction. It states what? It states that mass can neither be created nor be destroyed in what? In a chemical reaction.
Chemical reaction.
Yes. Like for example, if let's say this is my beaker, okay, and here in my beaker, let's say there is 5 hydrogen and 5 Cl, hydrochloric acid. I'm putting in this beaker, okay, 5 hydrogen and 5 chlorine. So if I will do some reaction with this hydrochloric acid, let's say, so the output of this will be 5 hydrogen only and 5 chlorine only. It's not like after chemical reaction it will change into, the amount of hydrogen will increase or decrease. No, the amount of hydrogen and chlorine will same only. That's why it states that mass, the hydrogen mass is here 5, okay, and the chlorine mass is 5. So it states that the mass of hydrogen and chlorine can neither be created means the amount of mass of hydrogen and chlorine is not increasing or nor be destroyed. Destroyed means the amount of these two is not decreasing also in a chemical reaction. If I am doing some chemical reaction with this, the amount of mass is not increasing, not decreasing, it will be constant. Okay. So this theory was given by that two scientists. It states that your mass can neither be created nor be destroyed in a chemical reaction. So these are the examples of this. Okay, so understood?
Yes, ma'am.
Okay, after chemical reaction also the amount will be same only. Now, okay, this means that during a chemical reaction, the sum of masses of the reactant and product remains unchanged. Like for example, here let's say this is my A, this is my B. Okay, my A is here, let's say 1 kg, and my B is here, let's say 2 kg. So this is my reactant, and what will be my product? C plus D. The sum of this, right? 2 plus 1 is what? 3 kg. So 3 kg will be the product of this two sum. Here I'm trying to explain is that if I am doing some chemical reaction with these two, A and B, the thing is, if this is 1, if this is 2, the whole will be 3. It's not like if I'm doing any chemical reaction, the thing is decreasing or this thing is increasing. No, after this chemical reaction, this 3 is 3 only, right? The 3 is equal to 3. It's not like a 3 is equal to 10 or 3 is equal to 1. No. After the chemical reaction also, your mass will be same. That's why mass can neither be created nor be destroyed in a chemical reaction. Okay, just a second, Razi. Okay, so yeah, so this theory, so this one is clear. This theory is clear, right?
Yes, ma'am.
Okay, so now the next one is what? The next one is law of definite, law of constant proportion. Okay, so here I will write law of constant proportion. Law of constant or definite proportion. I'm writing only pro. Okay, so now what is the definition of this law of constant proportion? The definition of this is, it states that in a chemical substance, the elements are always present in definite proportion by mass. What it says, it states that in a chemical substance, no one joined. Okay. It states that in a chemical substance, the elements are always present. The elements are always present in definite proportion by mass. Definite proportion, or you can also write constant proportion by mass. Constant proportion by mass. It means it states that in a chemical substance, the elements are always present in definite proportion by mass. Now, for example, here let's say I'm writing example of H2O. Let's say, okay. So here of hydrogen, here it's H2. है ना? So what it will be? It will be 2 atoms of hydrogen, like these two. It will be what? It will be H2. And plus what? Plus 1 atom of oxygen. 1 atom of oxygen, right? It will be like this. It will be only O. What will be the product of these two? It will be 1 molecule of water. 1 molecule of water, which is, this is what? This is 2 plus 1, means something like this. The 3 molecules of water, which is combining to become a what? To become a H2O. Now, see, it states that in a chemical substance, the elements are always present in definite proportion by mass. So here, in the elements of this hydrogen and oxygen, your atom is what? Is constant. It's not changing. It's not like if I'm writing, I can't write H3O or I can't write HO2. No, right? This is fixed. This is fixed by nature.
Yes,
2
ma'am.
atoms of hydrogen will be there, 1 atom of oxygen will be there. Then what we will get? We will get a full whole 1 molecule of water, which is H2. For example, if I'm writing NaCl, I can't write Na2Cl or NaCl2. No, it should be NaCl only. It means only 1 atom of sodium and 1 atom of chlorine, which is combining to form a 1 NaCl, or you can say salt. Right? So this states that one was law of conservation of mass, means your mass is getting conserved here. Conserved in the sense that it's not changing, or it's not increasing, or it's not decreasing. It's conserved. And here in the law of constant proportion, it means your atom is constant. It's not changing, it's not increasing, it's not decreasing. Okay. Your 2 atoms of hydrogen, your 1 atom of oxygen is combining to form a 1 whole molecule of water, which is H2. So understood this part, Razi?
Yes, ma'am.
Sure.
Yes, ma'am.
Okay, so let's say if I'm writing here H2O, okay, so what is the atomic mass unit of hydrogen? Tell me, which is the standard atomic?
Ma'am, is it 1?
Yes, it is 1. And what about the oxygen atomic mass unit is?
16.
16 unit, correct. So here it's H2O. It means 1 into 2 plus 16, right? It means 2 is to 16 also. I can write, if I'm defining the ratio of hydrogen and oxygen, I can write like this. 2 is to 16. It means the 1 is to 8 is the ratio of water. If you will take ice water, if you will take river water, or if you will take sea water, if you will take water like from anywhere in this whole world, the ratio of water will always be 1:8. It's not like if you are taking that dirty water or if you are taking a saline water, its ratio will change. No, the water ratio will be constant if you are taking the water from anywhere in this world. Okay, so this is the ratio. If you have to find the ratio for a given molecule, then you can find like this. You have to first find what is the atomic mass unit of particular element of hydrogen. Here I am writing of hydrogen and oxygen, and then what you have to do, you have to just do the ratio part. So if you will do this ratio part, then you will get this 1:8. Now first let me see this one. This is the best periodic table I got. See, like this, for example, this is the boron one. This is what the upper side is. See, this is the atomic number of boron, and here if I am saying of carbon, so carbon atomic number is what here?
6.
6. Yes, atomic number is 6. And what is this one? This is the atomic mass. So you already know the carbon atomic mass is 12, right? So you can.
Yes, ma'am.
So the atomic number is in the upper side. The atomic mass is in the below. And what is this? This is the name of the element. Means this is B. So this is boron, and this is the element symbol, means B. And what is this? This one is the S is what? S is state. And what is 2 and 3? This is electrons per energy level, and this 2.0 is electronegativity value. So this periodic table is very helpful because it's symbolizing everything. Now let me erase this. For here, let's say here for nitrogen, if I'm saying the nitrogen atomic number is, we all know it's 7. Its weight is what? Its weight is written over here. So its weight is 14. Element name is nitrogen. Element symbol is N. Okay, so here see it's written 3.0, means the electronegativity value of nitrogen is what? 3.0. Okay, and these two are what? 2 and, okay, see this. Why here G is written, Razi? Why not S is written? Tell me why G is written. Why not S? Because here is S is written, but why here G is written? Do you know?
Yes, ma'am, nitrogen is gas.
Yes, nitrogen is gas. That's why G is written. And below G, it's 2 and 5. Means 2 and 5 is the electrons per energy level. Okay, so this periodic table is very helpful. This one is red one, means, sorry, this is what? This is hydrogen. All the blue ones are alkali metals. You can remember from this periodic table only because this is very helpful now. The alkali metals, and what are alkaline earth metals? The yellow one. The transition metals are this one. The latinoids are these greens one. What is this? Antinoids. This sky blue. Metalloids, we already know that boron, germanium, silicon, arsenic, all are what? Metalloids. Metalloids means which is the combination of both the things, the metal one and the non-metal one. What is post-transition one? This pink. Other non-metals is this. Obviously, the nitrogen, oxygen, these are non-metals because these are gases. These are the halogens, the fluorine, chlorine, bromine, iodine. And noble gas are this: helium, neon, argon, krypton, xenon, radon. Okay, so this part you understood, Razi? The periodic.
Yes, ma'am.
Oh,
yes, ma'am.
And this also, I took screenshot and I just pasted here that it will be easy for you guys. Total, we already know the total. How many elements? 118. So these are what? These are the symbols of an element, and these are the atomic number. So beryllium is Be. You can memorize it up to 20. It's necessary to memorize, but you can memorize up to 50. It will be better for you. Okay, iron is Fe, nickel, Ni. Here silver, Ag. What is gold, Razi?
I remember. I cannot remember.
Not remember. And what is Au?
What, ma'am?
Au.
Aluminium.
No, aluminium is Al.
Oh, yes, ma'am.
What is Au? Let's see. Au is only.
Well, I have to learn these.
You have to learn this. Okay, some elements are important. You have to learn 20. You have to learn by heart. But see, the nickel, iron, Fe, magnesium, manganese, Mg, krypton, Kr. Here iodine only I. Barium, Ba. Yes. Silver, Ag. What is Fe?
Ma'am, iron.
Yes, iron. And here Pt is platinum. Ir is iridium. Here is what? These are not maybe necessary, but yeah, this one, the mercury, lead. Okay, and here in this one, fermium, no. But the thing is only just take a glance. But these some elements are very necessary. The symbols are very. Tin is SN. Tin is necessary. Antimony, iodine, xenon, barium. What about palladium, Pd? Okay, so go through this. Okay, go through this also, and this periodic table of elements also. Now, so we did this now. The law of conservation of mass. Here my mass is conserved, and here in this constant proportion, my atoms are constant. It's not increasing, it's not decreasing, it's constant. Now let's study about what is Dalton's atomic theory. Do you know?
No, I don't know.
Okay, so he was also the scientist, and Dalton was also the scientist. What he did, he gave more height to the words of that two scientists. The two scientists found the law of conservation and law of constant proportion, so he gave more theory than these.
Explanation, ma'am.
Yeah, the explanation he gave more. Now see, let's take a look in this example. What it's saying, copper oxide was prepared by two different methods. In one case, 1.75 gram of the metal gave, 1.7 gram of the metal gave 2.19 gram of oxide. And in the second case, 1.14 gram of metal gave 1.43 of oxide. Means in the first case, it's 1.75 gram of metal is giving 2.19 gram of oxide. And in the second case, 1.15 gram of metal is giving 1.43 gram of oxide. Now what we have to do, we have to show that given data illustrate the law of constant proportion. Law of constant proportion, one was law of conservation and the second one was law of constant proportion. Now here it's written in the case 1, see the mass of copper is this 1.75 and the copper oxide mass is 2.19. So the mass of oxygen, yes, it's asking about, okay. So here the mass of oxygen will be what? Mass of oxygen will be copper oxide minus mass of copper. This is my copper oxide, this is my mass of copper. If we will subtract this, we'll get 0.44 gram. Now in the first sample of copper oxide compound, we have to find the ratio. So this is what? This is my main, what is this? This is the mass of my copper. And what is this? This is the mass of my oxygen. And if I'm doing the ratio of this, we got 4:1. Now see, in the second case, the same thing, this, we'll subtract this, we'll get this. And we'll do the ratio of copper and oxygen. Copper is this one, oxygen is this one. So here also we are getting what? 4:1. So from these two calculations, we got what? From the above calculations, we can see that the ratio of copper and oxygen elements from these two is same. It means this example is what? This example is all about law of constant proportion, means your proportion or the number of atom will be constant. See, it's not increased, it's not decreased, it's same, right?
Yes, ma'am. The mass can be changed, but the ratio will not change.
The ratio will not change. Yes. There we did this example. H2O. The ratio was what? Of water?
It was 1:8.
Sure. Or 8:1?
No, ma'am. 1:8.
Yes, 1:8. It was 1:8. Good. So the ratio is not changing if we are doing. Okay. So what is this Dalton's atomic theory? So where should I explain? Here. Okay. Nobody's joined. Just a minute. Let me check. Advika also, Shizan also, they read my message, but they are not joining. I don't know why. Okay, so Dalton's atomic theory. So what is this? Okay, so the definition of this is, it provided an explanation for the law of conservation of mass and the law of definite proportion. And what about this scientist, the Dalton scientist? The first point of this that he explained is the all matter. All matter is what? Is made up. No, I'm just asking the definition that all matter is made up of very tiny particles, right? Which is called atom. Atom is what? Atom is the tiniest particle of what? Of a matter. Now, the second point which he gave is atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Like here, this was my atom. If I am pouring 5 gram of hydrogen and 5 gram of chlorine, so the product will be 5 and 5 only. Your atom is not created, your atom is not destroyed. But let's take example of this, the H2O. Here your 2 atom is fixed, and in the oxygen one, your 1 atom is fixed. It means it means that which your atoms cannot be created nor destroyed. Atoms are
yes, ma'am. Yes, ma'am. They will add and make 1 molecule of water.
What, Rishi?
Ma'am, they are not being destroyed nor created. They are just adding up and making 1 molecule of water.
Yes, good. Which cannot be created or destroyed, in a chemical reaction. Right. Okay. So first was the all matter is made up of very tiny particles. We all know that all matter, the atom is the tiniest particle. We all know. The second one is the atoms is not, means which cannot be created, means which cannot be increased, which cannot be destroyed, means which cannot be decreased. Okay, right?
Yes, ma'am.
Okay, so what is the third point? The third point is atoms of a given element are identical in mass and chemical properties. What? Atoms of a given element are identical in mass. Atoms of a given element are identical in what? In mass and chemical properties. Now, let's take an example. Okay, so tiniest one is atoms. Atoms cannot be created, atoms cannot be destroyed. And the last one is atoms of a given element are identical in mass and chemical property. Now, let's say we take one box, okay, and we put one element. Let's say this is my box, and in this box, I'm putting what? I'm putting helium. Okay, helium is He. This is my box. He everywhere. Helium. So this means what? The mass of helium is same. If I'll ask you about this helium and this helium, so obviously the two heliums are there in one in same box, so the mass of helium will be same only, right? It's not like the mass
Yes,
of
ma'am.
this is 10 and this is 20. No. So the mass of helium is same, and also the property of helium is same. Let's say the property of helium. Give me any property of helium.
Ma'am, they are lighter than oxygen.
What?
Ma'am, they are lighter than oxygen.
They are
Lighter.
lighter
Ma'am,
than.
yes,
They have
ma'am. They
low
are
boiling point. They also have low density, right?
density.
Low boiling point, low density. Now, these are what? These are the properties of helium. Now, let's say if I'm saying that, okay, this helium is having low boiling point, but this helium is not having low boiling point. It's not be like this, right? If this is having low boiling point, then obviously this will also have low boiling point. The properties of helium is same only if I'm asking about you about this, or if I'm asking you about this, if this is in one box, or let's say if this is not in one box. So the helium property is same only. The He property is same only. The Na sodium property is same only. If I am writing here 2Na, so these two properties are same only, and the mass is also same. Yeah. So the mass of helium
Yes,
is
ma'am.
it, and also what?
Ma'am, is it?
Hmm.
Ma'am, is it like the water from an ocean and from water from an ocean and the water from a river have same density and same boiling point?
Yes, it's having the same density. The ratio is same. It means the density is same, right? If we'll talk about any
Yes,
type
ma'am.
of water, saline water, aquatic water, home water, distillery water, the ratio is 1:8 only. So here, what is the? I'm explaining this third point. Okay, the helium mass of helium is same and the property is also same. Now let's say if this is my another box, and in this box if lots of hydrogen is present, so what it will be, what obviously the mass of hydrogen is same and the property is also same as the helium one. Now if let's say if I'll ask you, okay Razi, tell me about hydrogen and helium, will these two will have the same mass and the same property?
No, ma'am.
No, right? Only the hydrogen one will have the same property, and the helium one will have same property. So this point is what the atoms of a given element means. These are my element, helium element, hydrogen element. So the atoms
Yes,
of a
ma'am.
given element are identical in mass and chemical properties. Means it's same in mass and chemical properties. It will not change. But the two other elements, if we will ask about the hydrogen and the helium one, or any another two elements, so obviously their mass will be different and the properties will be different, but the same element will have the same mass and the same chemical property. So this point is clear,
Yes, ma'am.
and this one is also clear. The atoms are the tiniest one, and atoms cannot be created or destroyed. If we'll take the
Yes, ma'am.
example of H2 or anything, and this is also clear. Okay, good. And the fourth point which he discovered, this Dalton, was the atoms of different elements will have different masses and different chemical properties. Atoms of different elements will have what? Will have different masses and different chemical properties. So this is what the atoms of different elements. Here I took the different elements, the hydrogen one and the helium one. So atoms of different elements will have different mass and different properties. Do you agree with this point, Razi?
Yes, ma'am. You just explained in the third point.
Yes. No? The two different elements will have different mass only, but the same element will have the same mass and the same property. But the two different element, any two different elements will obviously have the same different mass and different properties. And the fifth point which he gave was the atoms combine in the ratio of small whole number to form compounds. Atoms combine in what? Atoms combine in the ratio of small whole number. Now, what is whole number? Tell me.
What, ma'am?
What is whole number?
Ma'am, a whole number is.
Who is the
Ma'am, I
whole number?
forgot.
Who is
Ma'am, I
not a whole?
forgot the definition. Ma'am, I forgot the definition.
You tell me what is the definition of whole number.
Ma'am, I forgot the definition. I cannot remember it at all.
Okay, you forgot the definition of whole number. Whole number means a number without fraction. That means this is a whole number. 3 is a whole number. 5 is a whole number. From 0 to let's say everything is whole number only now. The numbers that include natural number and 0 is whole number. Means whole number is including what? The 0 and natural number. What is natural number? Natural number is anything from 0 to infinite. So 0 and natural number is what? Is charge. Today nobody came and whatever. Okay. So this is what? This is a whole number. Now, atoms combine in the ratio of whole number. There, in the example of that H2O, atoms was combining in the form of what? 1:8. Na? So 1 is the whole number, 8 is also the whole number. So this point also proved that atoms combine in the ratio of small whole numbers to form compound. It's not like an atom is combining in the large whole number, 100 and 20. No, obviously we'll divide this. Okay? Okay,
Yes,
got
ma'am.
this point, Razi? Any doubt?
No, ma'am. No doubt.
And the last point which he gave is, it's already 47, the last one. The relative number of kinds of atoms are constant in the given compound. Same thing only. The relative number of kinds of atoms are constant in a given compound. Now, what is a compound? If we will take example of water, H2O. So here atom is constant. It's not H3 or HO2. No, the atom of hydrogen is 2 only and oxygen atom is 1 only, right?
Yes, ma'am.
So these theories are given by this Dalton. And what about that two scientists? What he gave?
Ma'am, they gave the law of conservation of mass and law of definite proportion.
And what is law of conservation of mass?
Ma'am, mass can neither be created or destroyed in a chemical reaction.
Oh, good. And what is law of definite proportion?
Ma'am, yes, ma'am, the atoms are always in definite proportion.
Yes. And what he gave that atom is the tiniest one. It cannot be created nor destroyed. Here, if the two elements are same, then they'll have the same mass and same chemical property. If we'll talk about the two different elements, then they will have the different mass and different chemical properties. And here the atoms will always combine in the whole number in the form of ratio. 1:8. 1 is the whole number. 8 is the whole number. Whole number is what? Whole number includes 0 as well as the natural number. And the last one, what he gave, the relative number of kinds of atoms are constant in a given proportion. Means your atoms are constant. If I'll ask about the H2, means your atoms are constant. It's not changing, it's not increasing, it's not decreasing. Okay, so got it? Every point, each and every point clear? Any doubt? Any doubt, Razi?
No, ma'am.
Sure?
Yes, ma'am.
But remember this, this periodic table is very good.
Yes, ma'am. I will start learning from today.
Okay. Okay then. Thank you. Bye-bye.
Bye, ma'am. Thank you, ma'am.
Bye.